Jai Hind to all. Myself Dr. Neelesh Kumar Gupta. I am working as a professor at Ajay Kumar Garg Engineering College, Ghaziabad. I am working in Department of Electronics and Communication Engineering Department. So today I will deliver another lecture for a subject of digital communication. Its AKTU code is KEC 601. And today's my lecture title is Basics of Digital Communication and Line Coding. In last lecture, I told you about the digital communication system. What is the meaning of digital communication system? What is the real role of random variable in communication, especially in digital communication? Now we will move further here, okay, like basics of digital communication system. So in this lecture, I will cover introduction to digital communication system. So its block diagram, advantages, limitation and practical digital communication system, where we can see why we use base modulation, okay, baseband modulation, and then we require the what? Line coding. The concept of line coding, their power spectral density, all I will tell you in this lecture. So these are my contents, okay, that I will tell you in this lecture. Now if we talk about the low pass signal means what? Like a low pass filter. It passes only low frequency up to the some low frequencies. Like low pass signal, this type of signal, it passes from 0 to particular frequency of this, okay, like a low pass filter. So low pass signal or band pass signal is a signal that can include the frequencies that are very near a 0, low frequencies, okay, by comparison with its highest frequency. For example, a sound waveform can be considered as a baseband signal. So, and our signal, this signal that I am talking and my audio signal is communicating here, this is also low pass signal, very low frequency. Okay. Like high pass signal, like also we study in the high pass filter. So it passes from this high frequency to further. So this will be cut off. Here your cutoff frequency this one, here your cutoff frequency this one. Now band pass signal, it means it passes through a some particular band, okay, from F1 to F2. So this is band pass. Now band stop, it means it only stops this band and remaining will pass. So these are the different types of signal that depends upon their frequency ranges, okay. So if we talk about low pass filter, it means what? If our signal is x of t is equal to sine of t pi t, so we know to change this signal into the sample signal or discrete time signal, we need the sampling frequency. So we know the sampling frequency will be the twice of Fm. So here Fm is this. You can calculate Fm from this equation, okay, and put here, then you will get what? Sampling frequency of twice of Fm. So in this way you can calculate everywhere your sampling frequency as per your signal, whether it is low pass, high pass, band pass and so on, okay. Next, like if we talk about band pass signal means what? Signal having band of frequencies ranging from some non-zero value to another non-zero value. It means band pass signal what? It passes your signal from particular band, from this, okay, F1 to F2, like in previous PPT, okay. So this is our band pass, from F1 to F2 it passes the signal here. So in band pass signal, what will happen? Here, what? For pass band is what? Pass band is from F1 to F2. F1 is your cutoff frequencies, lower cutoff, F2 is your upper cutoff. So bandwidth is what? Bandwidth will be difference between F2 and F1. It will be F2 minus F1. Okay. So similarly, baseband bandwidth applies to a low pass filter to baseband or baseband signal, and bandwidth is equal to its upper cutoff. So baseband signal is different. This is like a low pass signal. Okay, but band pass signal, it means it applies to a band pass signal, or you can say band pass filter that act as a band pass signal, because it passes a signal of frequency for a particular duration from F1 to F2, from lower cutoff to upper cutoff. Okay. So now if we take this example here, okay, what example? In this question, an example, a band pass message signal ranging from 4 to 6 kilohertz. What is the smallest sampling frequency required to retain the signal completely? So we need the sampling here. We know sampling frequency Fs is equal to twice of Fm. Here Fm is what? This is our frequency of baseband signal. So in case of band pass, it is different. If we talk about low pass and high pass signal, so Fm is, we know the maximum amount of the frequency available in the signal, you can take Fm. Okay. But in case of band pass, here our bandwidth is what? 4 to 6 kilohertz. So bandwidth is 2 kilohertz. So it will be what? In case of band pass signal, if you determine the sampling frequency, so it is different. It is what? This is 2 kilohertz. So 2 into 2. So it will be 4 kilohertz. So in case of band pass signal and simple baseband signal, low pass signal, high pass signal, so sampling frequency will be different. So you have to keep in your mind the sampling frequency will be different in case of band pass or baseband or low pass signal. Okay. So in this, because this is band pass, its quality is characteristic what? It passes through particular band. So we have to take that band duration only. If I am talking 6 to 8, so 8 minus 6 is equal to 2. If I am talking 11 to 15, so 15 minus 11, it means 4. So in this way you can take your sampling frequency for recovering your original signal completely here. Okay, that you have to keep in your mind. Now this is the basic block diagram of digital communication system, that also I told in my last class. This is very important. You have to keep in your mind what will happen whenever we apply digital communication system. So these are the blocks, different blocks that you can use under the digital communication system. Okay, so always remember source encoder decoder, channel encoder decoder, okay, and modulator, demodulator, channel, and so on. The remaining things are same. These are the new for you, I hope. Okay, source encoder, source decoder, channel encoder, channel. Source encoder, what it will do? They encode and decode your data along with compression and decompression of data, because we know in digital communication our data is very big, so you need compression there. Okay, that's why compression and decompression will be there using the source encoder and source decoder respectively. Similarly, channel encoder, channel decoder, what they will do? Channel encoder and channel decoder perform the error controlling task in digital communication system. Error controlling means what? They detect the error, and after detecting the, they correct the error. So error detection and error correction will be there through the channel encoder and channel decoder. So lastly also I told this block diagram in detail. Okay, again I summarize this block diagram, and these are the advantages also I told you in my last lecture. Why I am again and again repeating? Because these are very important that you have to keep in your mind. What are the benefits in digital communication over your conventional analog communication system? Okay, so in terms of distortion, noise, reliability, cost, crosstalk, flexibility, detection, correction, security, privacy, multiplexing, and so on. So these are the advantages. Similarly, there are some limitations of digital communication system. Loss of information may occur due to sampling process, because sampling तो हमेशा होगी. क्यों होगी? Because you are doing here digital communication. It means at first you have to convert your analog signal into the digital. The first step is for that what? You have to change your analog signal into its sampled or discrete signal, and that is possible only through the sampling. So sampling is mandatory in digital communication. So loss of information may occur in this time. Now more bandwidth is required as compared to analog transmission. Processing is typically complex, and synchronization also will be the complex. So these are the some limitation disadvantage you can say in digital communication system. Now this is my fundamental building blocks of digital communication. So practically what will happen? These are fundamental basic building blocks, and in unit number 2, digital communication basics, the unit number 2 of KEC 601 title is what? Basics of digital communication. So this is the fundament, these are the fundamental blocks. What will happen? So at first your message signal is coming from in terms of M of t. Now source encoder, it encodes your message signal in terms of digital data 10001 form along with data compression. Okay. So source encoder produce this data. Now it will go to baseband modulation, and that is called line coding. This is also modulation, baseband modulation. What will happen? This digital data converts through this into appropriate electrical signal in terms of waveform, suitable waveform, and that is possible using the only line coding, and this is called baseband modulation. It means without any superimposing or adding high frequency signal like carrier. So this is baseband modulation. Why we call baseband? Because it modulates, it process our low frequency baseband signal further for communicating appropriately. So baseband modulation means what? You are converting, because this 1010 cannot communicate. Your signal will communicate in terms of some waveform, electrical signal and so on, not in terms of 1010. Okay. So there is a need to convert this digital data into some appropriate waveform, and that is possible using the baseband modulation, and for which what we study about the line coding. So line coding की जरूरत ये है. So you now I hope you can understand the need of line coding in digital communication system. Now, so simple digital carrier modulation we can use here, ASK, FSK, PSK and so on. Now it will go to the multiplexer. Other signal also will go. Multiplexer means many into one. The several signals are combined, and finally at the output single signal will generate in the output. Okay. So multiplexing will be there using the FDM or TDM and so on. Now channel, across the channel we are communicating our signal. Now regenerative repeater and so on, and we will get the output signal in this digital communication system. So here regenerative repeater. So हम बार बार बोलते हैं, और what I told you also, the noise is less in digital communication. Why? Because everywhere here regenerative repeaters are employed. Regenerative means what? Again they generate the signal or clean the signal, and after cleaning and new generation of signal, that signal will be amplified by the regenerative repeater, and signal will go further in through the channel. So regenerative repeater means again and again you are regenerating or new signal you are generating. After generating, you are amplifying those signals through the regenerative repeater, and your signal will go through the channel. So, this is the very biggest advantages of digital communication, that we are using here regenerative repeater, जो सिग्नल को दोबारा क्लीन करते हैं, जनरेट करते हैं, बूस्ट अप करते हैं, देन प्रोसीड करते हैं. And this feature is not available in analog communication system. So, this is the very biggest advantages of our digital communication system that you have to keep in your mind. So, I hope that all will be clear to everybody. Now, what multiplex? I am talking about the multiplex. So, capacity of physical channel like coaxial, optical fiber for transmit data is much larger than the data rate of individual sources in digital communication. To utilize this capacity effectively, we combine several sources, several signals by means of digital multiplex. That is why we require the multiplexer here. Now, digital multiplexing can be achieved through the using either the FDM or TDM. Okay, and these all the signals will go simultaneously. Okay, through the multiplex. Now, regenerative repeater. This is the very big advantage of digital communication system. Regenerative repeaters are used at regular space interval. Okay, so in digital communication, whenever you perform the digital communication, so at regularly spaced intervals, you are using the regenerative repeaters along a digital transmission line to detect the incoming digital signal and regenerate new signals like clean signals for further transmission along the line. This process periodically eliminates an accumulation of noise and signal distortion along the transmission path. So, this is the very important advantages and characteristics of digital communication system using the regenerative repeater at regularly spaced intervals along the transmission line. So, ability of such regenerative repeaters to effectively eliminate the noise and signal distortion effects, one of the biggest advantage of digital communication. So, इनका वर्क ही ये क्या कि नॉइस को और किसी तरह के डिस्टॉर्शन को एलिमिनेट या मिनिमाइज करना. That is possible in digital communication through these regenerative repeaters. Now, we come on line coding. What is the meaning of line coding? It is used to transmit the digital signal in terms of 1010 over a channel. So, 1010 we want to communicate over a channel. So, that is not possible that 1010 you communicate along the channel. You have to convert that 1010 digital signal into some appropriate waveform or electrical signals. Okay. So, converting digital data, that digital data into digital signal in terms of some waveform or spikes or signals, we need what? Line coding. So, line coding convert the digital data into digital signal. What? It is used to avoid inter-symbol interference, overlapping of the signal, obviously. Now, there are various types of line coding. Okay. So, some popular line codings are unipolar like O, K, on off keying, polar, bipolar. In this also we can categorize these line codings into RZ and NRZ, not return to 0 and return to 0, Manchester coding and so on. Okay. So, now properties of line coding. Line coding, what I told you here कि why we are using line coding. Line coding, what performs the function in digital communication, that I told you. But the properties of line coding. Transmission bandwidth should be as small as possible. Power efficient for given bandwidth and specified detection error rate. The transmitted power should be as low as possible. Error detection and correction capability. It is desirable to detect and preferably correct detection errors. Adequate timing content. It should be possible to extract timing or clock information on from the signal. So these are the some important properties of line coding. Okay. Now if we talk about unipolar, uni means one polarity. Unipolar means that is having only one polarity. So only one voltage level is used. That's why it is called on off. One voltage में एक बार use करेंगे, एक बार use नहीं करेंगे, on off. Oh, okay. King. So if one is there, so pulse is present. If zero is there, pulse is absent. Further, these are of two types: not non-return to zero and return to zero. NRZ and RZ. So unipolar means only you are using one voltage level for one. Otherwise, your voltage level is absent. Your pulse is absent, off. So this is the way. These are the waveforms for unipolar NRZ. It means unipolar line coding in case of non-return to zero. So bit 1 represents the pulse of full duration and amplitude V, and bit 0 represents off pulse. So this is our simple clock. Now this is our data. Okay, in terms of 1 0, this is data. Randomly I am selecting here. Now as per this data, unipolar NRZ waveform we can draw. Okay, so the unipolar NRZ line coding. So what I said, for bit 1, pulse of full duration of voltage V. Okay, this. For 0, your pulse is off. So of amplitude of 0 volt it will be there. Now for 1 again, it is full pulse of voltage of V. Otherwise again for 0 it is off. Then 1. So in this way we can draw, we can check unipolar NRZ system. Now unipolar RZ. RZ means return to 0. Now here bit 1 represents the pulse of half duration followed by return to 0 level. That is, half of the bit duration remains high, and after the half it immediately return to 0, because what I am telling here, return to 0, which shows the absence of pulse during the remaining half of the bit duration. It is for bit 1. For bit 0, only it shows the off pulse of 0 volt amplitude. So again here our clock, generalized clock, this is our data. I am taking this data randomly here. Now unipolar RZ. Okay. So one, what I told you, in 1, for half duration it goes high. Okay. After the half duration it returns to 0, and for remaining half it remains 0, off pulse. For 0, our pulse will be half, off pulse, 0. Again 1 is there, so for half duration it will be 1. Again after the half, again it returns to 0, and for remaining half it will be off, in off condition. For 0 it will be in off condition, for 0 it will be off condition. Again 1, for first half it will be 1, for second half it returns to immediately 0, and pulse will be in off condition. Again this one, and simple. So in this way we can line code using the unipolar RZ. That was unipolar NRZ. This is unipolar RZ. मतलब return to 0 level. In this, pulse is returning up to the 0 level. Now polar. Polar. In this, polar means what? Polar means polarity. Polarity means 2 voltage level. One represented by pulse of positive pulse G of t. 0 represented by negative pulse minus G of t, antipolar. Again these are of two types, not return to 0 and return to 0, NRZ and RZ. So polar NRZ, bit 1 means positive pulse, bit 0 means negative pulse. So this is again our clock, generalized clock. Okay. Now this is data, again I am randomly selecting here. Okay. So polar, in case of polar NRZ, for 1, what? It shows the positive pulse here of voltage V. For 0, this is 0, this is 0. Okay. For 0, what? Our pulse will go for negative pulse minus V. For 1 again it will be positive. For 0 this is negative. Okay. So negative means negative minus of V volt. Okay. This. So here for bit 1 our pulse will be of positive. It means it contains is in positive cycle sorry of plus V volt amplitude. For bit 0 it shows the negative pulse of amplitude minus V volt. So in this way we can draw the polar NRZ line coding. Now polar RZ. RZ again if it bit 1, so for half positive pulse for half duration followed by return to 0 level. Similarly bit 0 negative pulse of half duration followed by the return to 0 level. मतलब 0 हो या 1 हो, our signal return to 0 level. So again our clock, our data and this polar. So 1 is there, it means it is positive pulse for half duration and again it returns to what? It returns to 0. Okay. Again it remains 0 for my what? 0. Again it will go for positive half minus V for half duration and other half duration return to 0 and remains in 0. Similarly here. Okay. So this is our what? Polar RZ waveform. Polar RZ line coding. Okay. Now bipolar. Bipolar means polarity plus bipolar. दो तरह से polarity in two ways. So we can say here plus, minus and 0. 3 voltage like example AMI. And this is also called DO binary signal. So for bit 1 alternating voltage level of plus V and minus V. So first one is coming, then plus V we have take, and again alternately again one if come, so you have to take the voltage level of minus V. And for 0 represent by absence of pulse in the like an unipolar form. So again it will be in terms of NRZ and RZ. Okay. And you can show here bipolar NRZ signal and bipolar RZ signal. It contains 3 voltage level, okay, plus, minus and 0. Okay. And as per the condition you can draw the waveform for NRZ and RZ bipolar line coding waveforms. Now these are the examples you can see here in case of RZ, polar, bipolar, okay, unipolar, RZ, NRZ, polar and so on. Now line coding we study here, but for their analysis, okay, because we are studying communication system, so frequency domain analysis is always mandatory. So for that we need to calculate power spectral density of line coding scheme. Power spectral density means what? Power per unit band. That how much power is distributed along the spectrum of the signal. Okay, that is power spectral density. So a line code is the code used for data transmission of a digital signal over transmission line. This process of coding chosen is to avoid the overlap and distortion of signals such as ISI, inter-symbol interference. The function which gives the distribution of power of a signal at various frequencies, or you can say along the spectrum of the signal in frequency domain, is called power spectrum. So for calculating a power spectral density there are some steps that you have to keep in your mind, then you can drive PhD for any line coding scheme as per these steps. Like at first you have to calculate the Fourier transform of the pulse at first. Now you calculate autocorrelation function of the pulse. Now finally calculate PSD power spectral density. Finally you can calculate after calculation of Fourier transform of pulse and their autocorrelation with the help of Wiener-Khinchin theorem. Wiener-Khinchin theorem is what? It says generally PSD in autocorrelation of pulse or signal forms Fourier transform in each other, and they are Fourier transform pairs. So then you can calculate PSD. So everywhere, for any line coding scheme, you can use these steps for calculating the power spectral density. Okay. So this is power spectral density of line coding scheme. Now these are the comparison, okay, of line coding scheme in case of NRZ bipolar Manchester. So these are different line coding scheme, and we can also plot the graph between these line coding schemes, okay, through this graph. Now these are the comparison in terms of transmission of DC components, signaling rate, noise immunity, synchronizing capability, bandwidth required, cost of. So these are the comparison, okay, technical comparison. By this you can analyze which line coding is better to you as per your application, okay. So now baseband transmission. So what through the line coding, if you are communicating your digital signal, so this is called baseband transmission without using any carrier signal. That is the line coding. So this is again diagram I am showing here, okay, process of line coding, okay. So you are converting your digital data into digital signal or appropriate waveform for communicating along the channel, for propagating the digital signal along the channel or transmission line. Pulse shaping, another feature of the what digital communication system, okay. It avoids the overlapping or avoids the dispersion in the pulses, okay, and so on. This is the pulse shaping, okay. Now pulse shaping, okay, this is the advantages of digital communication, okay. PSD you can be controlled in two ways, using the line coding and pulse shaping. So pulse shaping is more important than line coding. You can control the PSD, power spectral density. Main purpose of pulse shaping is what? Is to eliminate or reduce ISI income. ISI means inter-symbol interference. Main reason of ISI is due to the band limited channels and multipath. So this is the, you can understand in short about the pulse shaping. This is the advantage of digital communication, and these are the textbooks that you can refer for this subject, digital communication digital communication, okay. You can also see digital communication system, okay. Its AKTU code is KEC 601. So thank you very much. If you have any query, you can contact me on this email ID, okay, and also you can contact me in the department. Thank you very much.